So the previous example had some results in it that are important concepts when discussing probabilities, and they're summarized in this box below. So probability properties. So first off, the probability of an event is always between 0 and 1 inclusive. Okay, that's how we defined probabilities initially at the start of this chapter. If the probability of some event is exactly equal to 1, so not that it was like 0.99999 and your calculator happened to round it or you rounded it to that, but is actually 1, then it will happen, and it's called a certain event. If the probability of some event is exactly 0, again, not been rounded to that, but exactly 0, then it can never happen, and it's called an impossible event. And then in statistics, well, not in statistics, but in mathematics in general, this big capital letter sigma from the Greek language, this means sum. So if we were to add up the probability of all the outcomes in the sample space, that always has to equal 1. And we saw that with the very last part of the problem previously. So as we're looking at example 4.2.3, we're going to calculate some theoretical probabilities looking just at a standard deck of cards. Okay, so we've got 52 cards here. We've got our 4 suits, spades, hearts, diamonds, and clubs. And then again, ace up through 10, and then jack, queen, and king. So again, you do not need to memorize anything about decks of cards. Again, it's just a picture that's given so that we can compute some other probabilities that were and still are of interest to people who play lots of card games and gamble. But again, we're just going to use this picture to look at, again, some of these other probability rules. So the part A says, what is the sample space? And the sample space basically is just all of these 52 cards. So each of the 52 cards has the same chance of being chosen. They're all the same shape and size. So if we randomly just pick a card out of the deck, any one of these 52 cards has the exact same chance of being picked. So part B says, what is the probability of getting a spade? Okay, so a spade is this top row of cards here. And so we so again, this is our event. So we're going to let A be getting a spade. And if we go up to our listing of cards here, our event space here, we're going to have our ace of spades, 2 of spades, 3 of spades, 4 of spades, and so on. 5, 6, up to 10, and then we have our jack, queen, and king. And so in this case, if we were to compute the probability of getting a spade, if we count all of these cards, there are 13 in the deck that are spades out of a total of 52 cards. Again, since every card has the same chance of being chosen, we can use the equally likely rule. Okay, so here again, we're going to use the equally likely rule. So we get 13 out of 52, or if we simplify that on our calculator, or just visualizing it in the picture, that's 1 chance out of 4, or a 25% chance of that occurring. Right. Part C asks for the probability of getting a jack. So here our event, we're going to let B be getting a jack. So our event space there, if we go up to the deck of cards, we have a jack of spades, a jack of clubs, a jack of hearts, and a jack of diamonds. So again, using the equally likely rule, we can say that the probability of getting a card in this set there are 4 jacks out of 52 equally likely cards. So again, 4 out of 52, or again, if we either by the picture we can see it, or if we use our calculator we can see that that is about 1 in 13 chance of occurring. Alright, so for part B, it asks us for the probability of getting an ace. So our event here is getting an ace, which means our event space, if we go back to the sample space and grab our aces, we have ace of spades, ace of clubs, ace of hearts, and ace of diamonds. And so that means, again, using the equally likely rule, we can just count the number of cards that have aces on them, which is 4, out of the total number of cards, which is 52. Okay, so there's also a 1 in 13 chance of getting an ace, same as the probability we just computed for getting a jack. Alright, so for part E it says, what is the probability of not getting an ace? Okay, so here, our event is not getting an ace, which, if we use the equally likely rule, we're going to get a different way to compute this here later in this chapter, but this event space D, we would list all of the cards that were not aces. So we would have 2 of spades, 2, 3, 4, 5, up to 10 of spades, jack, queen, and king of spades. We would also then list the same thing for the clubs, so we'd have 2 of clubs, up to 10 of clubs, jack of clubs, queen of clubs, king of clubs. We'd also do the same thing for the hearts and diamonds. And so if we actually go and count all the cards in the deck that don't have aces on them, we get 48 out of 52. So something that we should notice here, though, is that if we pick a card, it's got to be one of these. Either we got an ace or we didn't get an ace. So we should notice here that the probability of this event C plus the probability of event D, these were equal to 1. Okay, so another way that we could have got the probability of not getting an ace is we could have said all the cards, 100%, and then just taking away the 4 that didn't meet the condition, the 4 out of 52. So that also gives us the same answer of 48 out of 52 with a lot less cards to think about, just the 4 with the aces instead of the 48 without. Alright, so part F says, what is the probability of getting a spade and an ace? So again, remember, and means the card has to match both categories. It has to have a spade on it, and it has to have an ace on it. So again, we're going to let D be getting a spade and an ace. So, oh, and actually we already used D, so let's change this to an event E. Again, the letter doesn't matter, but I just don't want it to overlap with our previous part here that we get confused. So our event space E, if we go back through the deck of cards, there's only one card that has an ace and a spade on it. Okay, namely the ace of spades. Okay, so the probability of randomly drawing a card and getting a card that has a spade and an ace on it is just 1 chance out of 52. But now part G asks us for the probability of getting a spade or an ace. So again, the card needs to meet at least one of these conditions. So if it's got a spade on it, it's okay. If it has an ace on it, it's okay. And if it has a spade and an ace, okay, then it's actually in both categories, but that's okay. It has to be in at least one of these categories to meet the condition here. So for part G, we're going to let F be the event of getting a spade or an ace. So our event space F. So we're just going to start with, it has to be at least one of these. So we're going to first just list everything that has a spade on it. So we've got the ace of spades, the two of spades, on up to the 10 of spades, jack of spades, queen of spades, king of spades. Or an ace. So now we're going to list everything that we haven't already listed in the set that has an ace on it. Okay, now the ace of spades is already in here, so we're not going to list it again. But we also have the ace of clubs, the ace of hearts, and the ace of diamonds. Okay, so now if we count all of these, so all of the spades, there were 13 of those, and then we added 3 more aces here. So our probability of getting something in this set to happen is going to be 16 out of 52. So again, if we take our deck of cards of 52 cards and we pull out every card that has a spade or an ace, or both, because it's at least one, so it could match both categories, we would pull out 16 cards, namely the ones that we have listed here in set F. Alright, so part H says, what is the probability of getting a jack and an ace? Okay, so our experiment here was just picking a single card. Okay, and so if we're looking through our deck of cards, so again, we're going to let G be, so here's our probability of, so here's our event, is going to be getting a jack and an ace. So remember here, our experiment is just picking one card. So if we pick one card out of the deck, and as we're looking through them, there are no cards that have a jack and an ace on them. So our event space G here is the empty set. There are no cards that meet that condition, so the probability of this event happening is 0 out of 52. Okay, so this is what we call an impossible event. Okay, it absolutely cannot happen. Part I asks us for the probability of getting a jack or an ace. So again, our event here follows the words probability of, so our event here we're going to let H be getting a jack or an ace. So again, we need to pick the cards that have jacks on them, or they could have aces on them, or they could have both, although we know from part H there are no cards that have both. So here if we list our event space H, so again it's an or statement, so it just needs to be in at least one of these categories. So I'm just going to start by listing all the jacks. So we have jack of spades, jack of clubs, jack of hearts, jack of diamonds. And then I'm going to add to that the aces from the deck, and making sure we don't list anything again, but again, none of these are aces. So again, we would have the ace of spades, the ace of clubs, the ace of hearts, and the ace of diamonds. So in this case, if we count up the cards that either have a jack or an ace, there are 8 such cards in a deck of 52 cards. So our probability for this event is 8 out of 52.